Hello guys, it's been a long time. This is a video on some side thing I was working. Of course, that's not the only thing I was working. I was working on some other things that more more interesting than this one. That they're just not finished yet. So there is a lot of things in the background, and probably also go back to 3DO, but the last few months I was doing things on Pentium PC DOS, like normally I was working in C on a incoming demo for Pentium. I guess it will be released somewhere in the future. So I stopped working with 3DO for a long time. But on the sides and some mornings I got some nostalgia. I got some nostalgia of the time I used to code software rendering on Qbasic. And I started looking with a new eye, with a modern eye. I started looking on Qbasic, and also first I went on Fat Code. We used to be doing Qbasic demos, which is weird. I did, I think I had this is a free basic demo I was doing. There's no arrow to go. The colors are bad here. Yeah, but that's all free basic, and I decided to try from a new something on Qbasic, but with a modern perspective. With I know a lot of more things on how to optimize stuff now. Now that was my first one. I was doing these roto zoomers. I don't know if I can find them. Because one thing I did, I was looking at my old code out of curiosity and nostalgia. And I was looking at those plasma, this one and all of them, all of the four plasma. And I realized by looking some of that stuff that, oh my god, I can make them even faster. There are things I was doing that are easy to optimize. Even if I thought at the time I did some really optimized stuff, especially compared to some other demos. There is the sky is the limit. That's what I realized. You look at your old stuff that you think you have pushed, and it's not just you think you have pushed. Compared to other demos, some of my effects were running faster. So it's like I must have pushed something beyond what usually people push. And the next demo here, but I'm looking at the code now, and it's easy to see places where I can optimize. And there are things I didn't know about Qbasic too for further optimizations. Also, first of all, I was looking at things I didn't know. I was looking at some documents. Let me see. So there were some documents that were telling certain quick basic optimization tricks, certain things I didn't know about quick basic, and certain hacks. Also, most of them, and I was trying a lot of them. Most of them, maybe it's articles. Yeah, like this one. I was looking at this one. Some of these are arithmetic. That's not what helped me to optimize. And I was trying some of them. I was trying instead of that to write things like this, and it didn't prove to. I was making some benchmarks every day. Let's try this one. Let's make 1,000 loops or a million loops of that on that. Some of them obviously worked. Some of them might not be interesting to me. Yeah, for example, I definitely was doing that one to read big files in all of my demos. Read one character at a time instead on a buffer. You could have a bigger buffer and it will read once. I was doing basic stuff. I knew the thing. Of course, this is the integer division. This is the floating point, this is the integer division. This is something I already was knowing. Yeah, it's some of them are obvious. Lookup tables. Like, obviously, if you calculate this over x, move it outside. Yeah, that's the thing I'm always doing. But here's the thing. I'm looking at the plasma. And the plasma I have a loop over y and then a loop over x. And there are parts of the equation that I could have moved out. So even those fast plasmas or some other code, there are things that could be pre-calculated in the outer loop. Such are the things that I did on my old plasma fan, almost double the speed, among other ideas. So there are things I'm more frequently doing now. Now that's an obvious interesting. You know, basic had the const, but it's not like const of in C. This is more like a define. This is like you say define p. This in basic. Now in most of my code I have variables that changes, but I was looking at my old codes and realized there was the place that I wanted to have a value that I put a constant number. Like could be the screen width, but could be also a parameter that I changed it so that I alter the effect, and I left it like this. I never made it const because this one there is a way. I don't remember. There is a way in Qbasic. Now, first of all, I am in DOSBox 6 with a long variable name. And for some reason, I cannot. If I try to compile, it fails, and I have to compile from another place. But anyway, normally we compile from here, but you could compile. I think it's BC. You could give your name BugoBus. I don't know if it will work from here. Maybe it's not gonna work. You have to. Oh, I don't have edit. What the hell? So there is a way to look at the generated assembly language, and it's very interesting because you realize how Qbasic does things. This is gonna be the basic listing. And not the assembly listing. I think it's AS or something. Yes. I don't remember, is it? So there is a way, I don't see it now. ATXT. No, it's not that. I need to remember. There is a way. Ah, look, I have an old example. That's a. there's a way to display the assembly generate code that QuickBasic does, so that you see how it works. And I figure out a lot of things. For example, I figure out Qbasic is the most obvious. Okay, it's 80088. It's XT code. It's not even 286. It's 80088, I think. And the most obvious thing for fixed points, if I do, there is no shift. But if I do A divided by 256, it's gonna make, I think, oh no, if I do multiply, it's gonna make, I think it's gonna make an SHL. Maybe it's making an A arithmetic. Is it ASL? I don't remember. Damn it. Suppose it's doing SHL. It's gonna do an, it's gonna move AX comma A, and then it's gonna do shift by 1. Shift by 1, 1, 1. It's gonna do that. And I also tried the, this is the highest, because it's 16 bit. It's gonna do that 15 shifts in a row. So I realized that, and there were cases that I optimized a rotozoomer or a plasma. If I was to multiply by number, it was preferable to store that in a LUT and use the LUT instead. I mean, in Qbasic it would be, yeah. But if the number is like 4 or something, it's gonna be that, and it's gonna be okay, because it doesn't have something like that 286 only, and it tries to be compatible with the original. And unfortunately, I thought initially, if you make with the integer division, I thought it would do an SHR. No, it doesn't do. It does an idiv or something. It doesn't division, unfortunately. That's where I I had to use lookup table for the fixed point. There is no shift, unfortunately. And maybe I might try in the future PowerBasic, because I remember PowerBasic was an extension of, it wasn't an extension, it was like Qbasic, very compatible. But you could compile output for 286, for 386. That's what I remember. There was some CPU you can set. But the goal was to try to optimize for the original. My goal was to try to recreate some old stuff and make them even faster for the original. QuickBasic without inline assembly. Now we are allowed to do define segment poke and stuff, but there's a way to output the assembly's data and make a call absolute at the position, so you can literally write assembly in QuickBasic. But what's the point? The point is, what can I do just with plain pure QuickBasic? And whatever the tool it gives me, it might give me some tools that look like low level, and they are low level. How am I writing in the video RAM even? Define segment defseg AH000 and poke at the address. Things like that. And I realized there are some extra tools I didn't know. So that's the one thing. If you do that, if you do var equal, suppose this is an integer also. Now this is how you can make it integer, but usually people say defined so that everything are integer, or even underscore 2. For some reason, I learned to put this symbol. Now this is for the floating point. This is for the 32-bit integer, which is emulated as 216 bits. So it's not natively using the 32 bits of the 386, for example. So this is gonna be slower than this one, which is the default 16-bit integer. So if you say x equal, well, it's gonna do move ax comma var. Maybe there is a data segment or code segment. I think it's in the data segment. There is a data segment that will point to the QuickBasic variable segment that has to be 64K. So there is a limitation with. Unless you do something else and expand the space a bit, but then it's gonna have to read a variable segment and the variable offset. It has to do more, but suppose it's simple. Yeah, and it's gonna say, I don't know, move. But if you say const var, it's gonna say move x. It's gonna put it as a direct variable, and that's it. So that's an obvious thing I didn't know, and I found a few places. Maybe I had some screen width is on 320, and I was using it in an inner loop, and I realized by looking at the assembly, I realized that QuickBasic is not clever. If you have a loop and you do something, whatever. Even if you don't do something, it's not gonna optimize this. It's not gonna. It doesn't have an optimizer. Oh, you're doing nothing or you're doing something. But I realize, at least in my observation, if you do something, anything, this is gonna be a label. Move. Suppose this. Inc. I do things with x, and when it reaches here, it's not gonna do that. It's gonna do move again. Inc. A move a compare x to 100, say the label, whatever. It's going to, whenever there is variable, it's not going to, you have to think like that. So if now we'll talk about it. If I was clever and say, hey, maybe I can store variables so that they are reused. No, I don't have a good example. It might not matter. Things because whenever it sees a variable, it's gonna read a variable. It's not gonna say, "Oh, I can do some register allocation, and this can always be in a register because it's the loop." It's not gonna do it. It's gonna read it, do things, and at the end, it's gonna read it again, increase it, write it, and compare it. So it's such wasteful and some things. But if you know that you can either with the assembly output or you can write something and see what it produces, and you can see that maybe. And also unroll loops are massive in Qbasic because it doesn't optimize. It doesn't even optimize the basics. You put direct values, it's gonna be direct values. You put a variable, it's gonna read a variable. It's not gonna be clever. It's the same with unroll loops. Okay, move the calculation. He's repeating himself here. Outside. Okay, it talks about gas sensitive. I guess in the 486. Yeah, I mean that. Yeah, I always do the This is the external, and this is the. It's like in C. The external, I mean, yeah. If you increase Y, it's gonna go serial. X is gonna jump. Oh, he's doing it. Okay, this is confusing. He's doing it. I've seen that he's doing. I tried that and it didn't. It might work oppositely. Anyway, in Basic now, I tend to use a one-dimensional array. I think I tried it or even saw the code and I saw it's the opposite of that, but I might not be. So there are some of these things that were questionable. Yeah, these are the same. Make pre-calculations for them. No, he said sometimes I do that. It's like use a variable here to store that. Yeah, because this is gonna be. You don't have to care. You don't have to care about. Oh, if I put more things into many variables, maybe there won't be enough register, and it's better to redirect. Yeah, if you have some big calculation, you can pre-store them because the v1x is used here and here, and so whenever I tend to do that now. I tend to do that in C, but maybe you are polluting the code with too many variables and that means too many registers. But I tend to do this more in QuickBasic because regardless if it's this or that, this is gonna be stored in variable, it's gonna be read as a variable. It's still not gonna be used as a register, from my understanding. However, and it's an even better example. Yeah, okay, this is a table on a table. Yeah, this is repeating 3 times. This is the same point, this and this. So that part, yeah. So some of these are repeating, can be found twice here. So why not read them here? Yeah, yeah, those are obvious. But knowing that QuickBasic is definitely never gonna be as smart to see. Oh, this is the same as this. It's not even smart to see that. Oh, you're using this. I can put it in a register. So that's definitely thing. And I've used now. This is something I didn't know. This is a nice trick. This is how if you want to define an array in Basic, you say dim x 32,000. You can also say dim x. How was yeah? As integer, as float, as double. I think long is 32-bit. Or you can say as integer. Also check the limit. This is 32. This 32 as integer is 64,000 bytes. If you do compiler will complain. Interpreter will complain. Because it's going over the limit of a single segment. That's another thing that bothers me with what I'm gonna explain. So you might have a Z buffer, you might have a back buffer that you want to clean for the thing you're trying to do. You might want to do it regularly. And you would normally loop and clear. Except from dim, there is also a read dim. It's a read dimension, and it's like a realloc, I guess. But both dim and redeem will do this for you for free, and it's not gonna be in a loop. It's gonna be in some assembly written loop, probably more optimized, I guess. I don't see them doing rep stores though. I don't know how optimized they are. But it might be. Actually, I tried it and it goes faster. Yeah, I tried this. So that's something useful because what I was trying to do here to make a new 3D engine in QuickBasic. I had to clean my buffer fast. If I was using as a buffer, I would have to clean it. So this was a useful simple trick. Yeah, avoid multidimensional. Do it like that and index it yourself. Yeah, also when you write this, it's 0 for the QuickBasic. It's 0 to. So if you say dmix, you can actually refer x to, and that will be fine. It's not gonna be overflowing because it's really 257 values from 0 to 256 inclusively. So those are little things. Yeah, okay, that's the dynamic. I think you still cannot make a bigger. There is another reason for dynamic. If in Qbasic you say dma, that's already 64,000 bytes. And if you do, okay, let's make another array. Interpreter complaints. I guess it was some small memory model, 64K total for all variables. But if you do a dynamic, which some of my demos, if I'm not doing a single effect and I'm doing a full demo, this is, you gotta do that. There is not enough memory to do several effects. Unless you made with one array a memory pool and reused it, which is something I consider. Okay. Now the limit 64K or whatever memory left, probably less. Especially inside the interpreter. I had things that would complain inside the interpreter, but if I compile them into an exe and run it outside, it would be fine because the interpreter would take some of the 640 kilobyte. Now, that means that in some cases, if you say if you try to do something, it could possibly be, it could internally it could be move es comma a segment address or some and then it would say okay, move a comma es kato move es comma b segment. So unfortunately, when you do the dynamic, things might get a bit slower. It depends if you can have, okay, you could do, I think you could do static and then dynamic, so that at least this is on your basic segment and other variables. So maybe some of your arrays are in dynamic. And I've seen code, I don't even think it does that. I think in some cases it might call something to get ES segment from variable. It might be even worse, or it might be doing that. I don't remember. Maybe there is a table of the segment at the... So it does the extra step, and imagine if this is a loop. So it's already, if you see the generated code, it's already a bit busted. But that's how some of my demos. I'm surprised they were still that fast. With all the unoptimized thing I see that Qbasic produces. Now I tried this one. This is something that would do it 0 to 2, but I'm not sure if it works. So yeah, the obvious thing, if you have multiplication by, you do it with an addition. Yeah, those are obvious optimization. This is how we write in the video ramp, define segment AJ00, the video ramp pointer address, and we use poke. Yeah, I don't use pixel set anymore. Integer is 16-bit, the longest 32 bits. There were cases that I needed the precision and I used long, but very rarely I try to avoid. Yeah, some of them are obvious, picking from video memory, slowing. Yeah, and even DevSeg does like that movie. Yes, come on. I think, or I don't know if I don't remember if this works directly or it has to do movie X, movie S, X. So whenever you do DevSeg, it changes the data, but it might also restore. It might have to restore if this is in the. If these variables are on another segment. Yeah, it might have to restore to the basic. So I'm not sure. There is the basic segment. There is the code segment, the data segment, and it might use ES for that. So during the loop, it might sometimes. No, okay, no. ES can point to that, and the DS, the data segment, can point to the variables. So I guess if one of these were on static, it would be using DS directly. Only if you have different big tables, all in the dynamic. Yeah, so you can have your regular variables that are not in dynamic. Here it says don't use dynamic. Yeah, see. To be able to do something like that and not have the compiler complain. This will complain even with dynamic. You can run quickbasic with this command to huge arrays, yeah, to be able to, which I never use. I try to keep my arrays small. I had to use dynamic for my demos. You select yes, accept. Yeah, that might be. I haven't checked that. And instead of mod, these are the obvious things you would do in C. Some of that stuff. Don't put the main loop in the main code. Really? Put it in a sum. Ah, it's just that the interpreter has less variable to wait through when you're in a sub. Okay, that's interesting. Is this only for the non-compiled version, the interpreter version? Okay, I might have missed the point. So I read that one, and then I read some other thing. I found another article that had more techniques. Anyway, I went too long with the video. So what I've done here is I was being nostalgic. Shouldn't have been so long, but I'm sorry. I was studying various things about QuickBasic. I was even studying things from other pages, even some weird techniques to hack the compiler. So I realized that back in time, I never did the real polygons. The best 3D I did was with dots. However, initially I found some of my old unreleased code where I was trying to do triangle rasterizer and Guru rasterizer, and it was bad though. It was some old bad code, so I didn't use it. I decided to start from the beginning and try to write a 3D engine. So I decided, okay, this one, these cycles are on Pentium 1. This is like the main machine I have at home. And I guess here, because it's DOSBox, it might be a bit faster because of no video RAM bottleneck, but not by much. And I started writing the Bugo engine, which, if I don't, which loads PLG and 3D. And I went slowly. I did everything. I did. Let me see what are the buttons here now. There. Oh my god. Do I have VSync? I don't have VSync. Shit. Do I not have VSync? I guess we're gonna have to do a 486 at 33. Ah, this works like works like a benchmark. After 15 minutes it will. And here I can change. I can put Guru. Ah, I have to change that. Oh, God, I realized. I don't even have a... You can do something like a funk thing or a Guru funk. The funk thing is... You see nothing because it's a darker funk. And it looks a bit bad. The Guru font, it's Guru shaded where an environment mapped blob is added. But you can, let's put it at the proper speed again. You can put, yeah, the common example is the torus. Ah, no, it's not, you do it here. So you have the flat shaded torus, Guru, and the environment mapped, which is a fungal blob environment map on a Guru surface. So it does the Guru shading, and on top it adds the environment. And I have set up the palette so that they blend nicely. And it was, I think it was doing something like that, like 30 FPS. And the heavier thing I had was, I don't know if it will work. Because I have changed some values about the maximum number of points and maximum number of polygons so that I don't have issues with memory when I'm working on the interpreter. Maybe it will work. Oh, that's buggy even, okay. This one is having bugs. Ah, no, I'm confused because of, yeah. That's the cow. That's the glorious environment map cow. Guru, and I think I have, yeah, I can change the 4 palettes. I don't know if I had the button to change the texture, maybe not. And you see some polygons disappear still. I think it was doing something like that on the machine, maybe 12 FPS. Or the bit was doing 12 FPS, but it's broken. So now am I gonna, it took me more time. I'm gonna show the engine. And my decision was, this could be flawed, so I will try to see if it improves. My decision is a lot of the structs, this is how you define struct. I try to keep them as integer, at least for the rasterizer. The rasterizer should be fixed point. But my decision now, single is for float, and double is for 64-bit, for the 64-bit float, and single is for 32-bit float, I think. My decision was to do the transformation in floating point, so that I make things easier for me as I was running on Pentium, and floating point is faster on Pentium, and it seems so. Oh, there is another thing though. There is a tool called FX. Now there is a history about that. I don't understand. There was a bug with a floating point when QuickBasic is going to use the FPU. If you don't have, it's gonna run with emulation. It has to do something with vector interrupts. Maybe if you try to call a floating point opcode and it doesn't exist and it gets you an error interrupt, then to replace it, else move on with it. And there was a bug that made the floating point much slower in QuickBasic. So if you do maybe bit 3D, and I will try to do probably the dots. It takes a long time. Okay, this is with FX on. It takes a long time because I'm actually real time calculating the normals. I haven't stored the normals, so I'm going through every polygon of this, and I'm gonna stop it. It's a 81 FPS for the. How many? Is it 2700 dots? And if you do this, you're going to unload it. And load it again and try to. So that was that thing too that I have to run. And there is a way to run it from inside your program, to run it automatically. But I have not used that. Man, this video is gonna be longer because there's so many things I want to discuss. I realized that I was spending time looking at those optimization documents. Okay, it's 77. It's not much less. Maybe on the real hardware. You see a difference on the real hardware. So I took a decision to this element. Now this could be flawed because this is the vertex 3D is where I store the points. And okay, I did it in integer so that it's 16 bits, so that when I define, I don't know how to make this smaller. There's a point where I'm defining all my arrays. Line. Oh my god, the movement is. These are all my arrays with all the structs, and I have screen vertices. Element 3 is the final vertices, which I will feed to the polygon rasterizer. And object vertices are those. Vertex 3D. I do max vertices -1, as you see, because it's gonna be inclusive of the max of vertices 512. Also, that object had more. I guess this is not compiled. I reduced the number and recompiled. You can technically run it from here. Oh, can you? Oh, I know what I did. Okay, this is a version where I paused. And there are more subs here. I know what the hell I did, man. Yeah, I think here I post. No, it's not here. What the hell? Maybe I didn't save it. Oh no, okay. No. You should have that. It's gonna move outside if you do. 0.5. Okay, I did post it because I was investigating an issue when I was porting this on. Yeah, I actually made a C port. This is how it runs from the interpreter, as you see. It's still pretty good, 23. If I run it from here. Now I'm telling you, this is not the real frame rate you will see on the. I think you might see something closer to 80 or 100. I don't remember because of the video bottleneck. Because we are still writing pixel per pixel in the video RAM, and I'm gonna show you also how. Because there is another problem. Okay, the other problem is in all of my effects like the plasma and so on, a lot of these effects they would write directly to the video RAM, and that would be a problem because of the array stuff. And I would have to do, if I wanted to have a frame buffer, because if you do polygons, things are gonna flicker. You are writing all over the place at random. You need some back buffer, and VGA doesn't provide that unless you used Modix, which I didn't. So I had to do screen upper that's also S integer. This is painful because you cannot, if you do this, interpreter complains. It's over, it's 128k, almost. So unfortunately, it wasn't easy, and there isn't no char integer. There is char dollar, but that works. You need to do ask conversions, which are slow. So there was no way to have a back buffer. And previously we would do defseg aj poke. And that would be byte. That would write a byte in this address. So that would work. And I realized if you see on my, I don't know, draw even there is a varseg. which literally can vram 0 plus 1. There is a reason I do it like this. These are some tricks I read from some, or I was looking at some code. And this is gonna return you a var pointer. Return the address of a variable. Var pointer and var seg. It returns the segment address and the pointer address in the classic DOS model. So I can take that screen seg. Where am I doing it? Maybe lower. And I can define the segment as screen seg, the start of the screen address plus an offset. So I can define that, an offset for my scan line, and then do a poke on the horizontal. And this is what I do everywhere. And the thing is, okay, suppose you wrote in the back buffer. How do you write the back buffer to the main screen? This is the thing that changed everything. That I could finally. I used to do defseg this and happily poke pixel. Now I can use the varseg variable. Okay, and I do some magic. There is a reason for that, and then some inner loop. And it works like so. I work like I used to work with the VGA address, but I can write to the back buffer, and now I don't need that. So this is 16-bit integer, but it's really 64,000 bytes. So I define it like that, but I know. However, if you see, that was the big thing that finally liberated me, and I could work. Because back in the day, when I was doing these dots, I think I checked I was saying, okay, read the Y position of the dot. If the dot is under 100, poke, write in the upper buffer at the position. If it's under, right? Imagine how bad the code would be, especially if I do the triangle rasterizers now. How bad it would be if I had to split it in two, and then I would copy those two buffers into VGA. And I would read the 16-bit value, but it would be an 8-bit value inside, which I would poke regularly on. But now, let me see. Let me see, because vram. So I define the vram as 0 to 32007. Why? Because I need to remember. Because this is some extra information for this buffer. Y7. So this is 0 to 7 header and 8 to 10. What are the data before? At 6? Ah, no, there's another reason why. Okay, this could be 0 to 32.1. But this is a padding for some other trick with a defined segment, because 0 to 7 in the 16-bit integers, 16 bytes. And there is something I do. See, it's And I read this as a trick. This is the segment plus 1. But you know the segment offset pairs 20 bits. This is how, so the 4 bits, the upper, is the start of the address. So if your segment is 0, it's at 0 bytes. If your segment is 1, it's at 1 off. And there was another, the initial code would not do that, would have the original, and I would have to do something like, I think, I don't remember, POG 16 plus. And actually not 16. If I did the 32,001 and not, because it's the 4-byte header, 12 bytes padding, I would have to do, I think, 4 plus, and that's an extra thing, and I even benchmarked it. It has to read this and add it to 4. It's a small thing. So there's a trick that pad that shit. And H is for header, and data starts here. So that I can set the segment plus 1, and that it starts exactly. And why is the header needed? Because I figure out there was a B, not a B load set. No, there is a put. Actually, I have used that put in another way. I forgot. Put graphics. Normally, what I would do in a, and I only did that when I wasn't using poke on my very first demo. It's not even here. In this demo, when I do that, what? I would load the original image, and then I would take horizontal scan lines with it's not below, is it? Oh my god. There was something that could capture. Get. So you can say after you display something, probably I will close the palette, I will make everything black so that you don't see that. And people were doing that. So I would load some graphic from the displayed in VGA and grab regions. And I could grab get 00 to, suppose the first scan line is at 00, 100 0. And get 00 to 101. Or that's on a loop. Why? And I think you put some array size. Now the array size had to be, say, 100 plus the 4 bytes for the header. Why? Because the header, it doesn't say you that. You don't know. You do it and you get it. Because that header I don't have it here. Sorry, but it stores size of the width, but what? I multiply by 8 in bits and the height in lines. So this is the width in bits. And why in bits? Because now I'm on screen. Yeah, you know, I'm in screen 13. I'm in VGA. But what if I... What if I set some CGA 4 bits per pixel, 2 bits per pixel, some EGA 4 bits per pixel, and EGA some. So if I change the mode, basic. But it doesn't like that one. Yeah, okay, it doesn't like because I changed the mode. Yeah, normally, depending on the mode, it would do. You are giving it a stream of data. It doesn't know what it is. You are telling it why not just put 320. That was the confusion at first. Why put 320 by 8? Because it needs to know the size of bits, and if I was to do that properly, now with the and also, by the way, there is a beload and be save. You can render. You can have a program that renders something on the screen with lines, with circles. You can design something and then the contents of an area of memory to an output. You can save. I think it was beload be save. Image file. So you could see in some early basic demos. Maybe I used it, maybe not. There are files that were in this format. Someone would draw something stupid and then grab it as a sprite, save it, and then in the main demo or main game there will be below this, put this on the screen. By the way, put is stupid. It's supposed to be used for sprite. I'm telling you, you put it in an offset, and I'm storing those values because it's the header that it expects before the data, and I'm storing them at 6 and 7 integer. I have the padding for the trick. Let's see, write video RAM, and I'm using the put, and see, I'm the start of what I give it starts at 6 and not the padded and it works. It reads the first two integer values, 16-bit, so it's 6 and 7, and it knows now that it has to read the following data, and it depends on the screen mode, so it knows that since we are in screen 13, every pixel is a byte, but it knows the width in bits anyway. If you put and this is I've made a full frame buffer 320 by 200 that is outputted as a sprite by Quickbasic with some faster assembly code than what I would do if I did a regular loop and read from video RAM from my back buffer and poked back to the video RAM. And I think I tried that too, but unfortunately, this is the funny. I thought, oh, that's also for sprites, so maybe you can move sprites around. It is for sprites. It was used for sprite. And maybe I can put it a bit outside so it will clip with the screen. You say, I wanted to clip with the screen. I wanted to move this. This is 320 by 200. If I move it even a pixel, it's gonna clip with the screen. It's gonna be outside. And I thought probably this put will handle because it's made for sprites that can go also outside of screen. No, fuck you. No, it doesn't even handle. So they made put for sprites, but doesn't clip outside. So you can use it to do some game that doesn't, the sprites are always inside. And I think this is stupid. Okay. I don't remember how I did this stretch. When I do that, every scan line is a separate sprite. So I decide to not. Here, every letter, it is a put character, but I also have it stored in a vertical scan line. So those who are rendered here, this and this and this and this are a single sprite. But those, I had to split it also in vertical scan lines, because basic is not, if you try to put this sprite here and it goes outside, it's gonna get an interpreter error. It's gonna be like, you try to draw me outside, partially outside of screen. It doesn't even, so I think the purpose of this put was for simple sprites, and they didn't even bother to make it partially clip with no. The interpreter said no, that's wrong. You shouldn't be doing that. But this one, yeah. So it's stupid. If I understand correctly, it's stupid that it doesn't work. You cannot partially, because I could have moved my screen a bit. I could have made my screen. I could have been rendering this 3D, and I could have make my screen shake. I could have made the screen shake, which would partially move it outside, and I can't. I will have to render in a smaller screen, and the nice thing is that you can change this in real time and change the size. I could be rendering and then change that. Ah, no. Huh. Hold it a minute. That doesn't seem right. Maybe I changed it in another place. Huh? I'm confused now. Is it, am I doing, okay, hold it. No, all of the modes, huh? Okay, maybe I'm changing that at the other places again. Ah, see, ugh. Every time I clear this, why am I setting? I'm doing the redeem. Oh yeah. Ah, see, did I see what I told you? I'm rendering. That was the trick. I'm doing redeem on this for faster clearing instead of doing a regular loop and clear it. But because I'm doing a redeem, it's gonna clear all the values, so I have to reset them. But if here I do that, see, it's rendering halfway. If I do some, okay, 300, it's gonna make a mess because the width is different. Okay, this is gonna, yeah, because the width is higher than expected. Man, this video takes a long, but it's interesting. If I made it 4 bits, it's gonna be half. See, so you change, yeah, okay. I'm resetting those values every time when I clear the video RAM. And I even tested some funky blur. Here is the thing. Blur switch. If blur switch is, and you see now, I use everywhere that I have that stuff. I use const now. That's something I never knew because it's gonna be like a direct value. It's not like the constancy, it's like the define the macro in C. So if this there is I I have a I also okay I have defined false and true. So if blur switch is 1, do the horizontal blur. Okay, I have to build that. Okay. There is another trick that someone uses. There are some cases. I don't know if I can hack it. There are certain stuff I did that you have to build. And it's not only gonna work outside because I might do something that overflows for some reason. So you might go over. This is gonna interpreter goes brr. Compiler doesn't care. And that's something that someone else used in a rotozoomer in the past. So he did a trick that the value would overflow, but it would be okay because it would overflow in the stable places. I don't know, is it because I do plus, minus? Ah, the clear blur junk. Now, it could be a bug, it could be anything. Let's comment this out. Yeah, it works. It's very slow from the interpreted anyways. So I have some things that will work. Will only work outside of the interpreter. Because I might be doing something that makes sense, but it might go out of bounds for a variable. And also here I'm doing a trick. See, I had an idea that since if I go on A8, A00, I would have to use pick. But then that would be very slow for them, the video anyway. But since I'm... But I can use pick from the var seg to do the blur, left pixel minus 1 plus 1. But I realized I'm doing those tricks on my DOS code on 386 and above. That you can technically, this is a 16-bit integer. So dirty blur 2 pixels at once. Works only if colors are... I'm doing the trick I did. So here I don't do the normal thing to get the var seg of the video RAM, and I work it like it was 16-bit integer. So you can do a lot of tricks like that. And I'm doing 2 pixels at once. And I have to end it with a value. So this is a trick I might have demonstrated for when I do things in 32 bits, 4 pixels at once, but it's specific to the algorithm. It's not a generic trick. And I managed to do it. I managed to make it work for things being faster. Why did I go to the blur switch? So you realize and I have a blur RAM where I do, and works only if colors are 0 to 63. And I do a different end to I'm not gonna explain it. So I realized that okay, I'm working with this weird VRAM that it's convenient and I can clear it with redeem and I can write it with a put and all of these are, it's both convenient, but if I want to fill it, I will have to just get outside the screen seg. I use a 32-bit integer because there are some issues, but it didn't seem to affect the performance much. This is the symbol for the 32-bit because this segment could be 0 to 32, but it could be 0, it could be any value. But unfortunately, this integer is minus the. That's the other problem. That there is no unsigned integer. And this one is 30-bit signed, which is minus 2 billion to 2 billion something, roughly speaking. And see, I was so excited with this project that I even tried to clean up things and have things. I see my old code, it's very spaghetti. Here is I have my structs very carefully. I was changing stuff, I was refactoring stuff, common consts. I do have the screen width. Oh my god, I found some other ugly stuff. And I very carefully named my variables. If you open something, there is always, there is a space here, space here. It's very well spaced and tabbed. It's very nice to read. I use const to read the other const. Now, the weird thing, Basic doesn't have pointers. I try to avoid complex structs for speed, and I have an object 3D. This is the struct for the single object, but I don't have a point. You cannot have a pointer. I have number of vertices, number of poly in this line, and number of poly. Do I have number of? I don't have a number. And I took a decision because hold it. I can't find it. What am I doing is I'm using a memory pool for everything, screen vertice, screen policy, object vertice. But those, okay, I could have had this defined inside the object and maybe redeem the object. I don't know. I could have an object struct that contains the object vertice, but I think I made the decision for performance that I rather have a memory pool instead of a struct that contains another struct that contains. So the object contains its own object vertices, which I have to redeem possibly, or. So I made a decision where some of the stuff are pools of vertices, and this one is 0 to max vertices. But this one, if I'm going to load more than one object, which I had the facility to load more than one object, but I display one object. This array might have vertices from more than one objects. because I think max. Okay, max vertices. Now I have max object and individual object vertices. I just put some numbers that work somehow. And I have a max object on screen. That's an approximation, average object vertices. Normally, in a previous code, this was like to 700 so that the bit is. But you can make it. If you do something higher, the interpreter is gonna complain. And even the compiler is gonna complain. But these max vertices will happen. Okay, but that's one. Okay, this is reduced. If I want to load the bit, I have to do it like that. It used to be like, did I like that? Like, okay, maybe I'm going to load 4 objects, and roughly speaking, on average they will find one object could be higher. Anyway, it creates a screen vertices. Let's say that is 2000, but from 0 to 499 is torus. From 500 to cow. Maybe cow is bigger. From 701 to 13 is cube. Do you understand what it's doing? So this is a memory pool, and all of the other are memory pools for all the objects. So now my object 3D has these offsets that start from 0. And where is it? Damn it. I think I have, as I either generate or load stuff, current object vertices, current vertex add. You see, and when I generate an object or when I load an object, that could be at 0, that could be at 100 because the previous one was filling it. And I do it for the poly indices, line indices, and everything. The vertex normals, polygon normals, everything is a pool. Load object 3D 3DO, load object 3D PLG. And I have a reset element add indices that I do it only once. So I have this pool logic, and I still suffer with memory. I do the dynamic for the big video RAM. For certain, the blob text is the environment mapping texture. This is a division array I use somewhere. And then I switch to static so that I guess the small things will be, those we will try to fit them in, those are my pools in the 64K, in the main 64K of QuickBasic. There's some weird arrays to pass things so that I don't pass them by arguments. So the rotation matrix and the inverse rotation matrix, this is flawed because I took the decision that make the transformation flow so that you don't have horrible issues with overflows, and it's easier to work with fixed point in the rasterization than the transformation. Do you remember FX? I have commented this out because it created problems. This is something I found from a code. See the credits. This fix that fixed the floating point. They did some hacky code, some intrusive code that they poke at certain addresses of in the service in the interrupts or something. So this is something I got because I thought maybe I can run fix at startup, but this created problem every time I was rerunning the code from the interpreter. I would get the editor corrupted. Maybe if you stop because there is an unload. I guess if you run it and something went down and it didn't unload from memory, if I control pause because something crashed and it never reached that point, this might be good if you make a final, let's say, so that the user doesn't have to run fx from outside for the faster floating point. So there are a lot of stuff. I'm having a benchmark version. Man, there are so many things to explore here. By the way, okay, I will go to that. And you can load some simple things like, okay, there's the chopper. Now this is more complicated. It's very impressive. I don't have wireframe for everything. And I realized I started running quick basic demos where people were displaying toruses and teapots. I have the teapot. It's very fast. I have some very simple objects. PLG. Now it's not gonna be 246. There's a bottleneck because this put that copies the back buffer to the video RAM. I think it still does it byte per byte. It does it more efficiently internally than if I do a regular loop in BASIC. So what I realized, I was running various quick basic demos where they tried to display 3D and they have the 3D teapot, they have some other objects, and they were running slow on my Pentium. You needed at least a Pentium 2 to see them kind of smoothly. But my code is pretty damn fast. Yeah, I might be bragging here compared to other 3D engine, and it's pretty. Here is a very low res. That's a low res torus. So I'm tempted to make a quick basic demo because I'm really pushing quick basic again. And there are cases where some of the code wasn't pushing, but the problem is memory. The problem is because I'm doing all that stuff. I'm doing weird stuff with those tracks, and I might be hitting a bottleneck soon with memory. With the interpreter complaining, the compiler might tell you I'm not compiling this. It might throw an error if you go over. And actually, I searched a lot of stuff on the internet. I didn't know this. I didn't know this fix. I didn't know this trick with the B put and B load. And I even have a free mem. There was a function in QuickBasic. Okay, it's not. It's on some mistake. Frame -1, and I kinda reported, and I am. -1 indicates what type of status you wanted there. -1, the size in bytes of the larger non-string array that could be dimensioned. The amount in bytes of unused stack space. Yeah, there are some interesting stuff. This is for the Yeah, the remaining space for the regular variables probably, if they are in the stack. Are they not in the heap? I don't know. And then I have the 3D object. The simpler is the head 3D. Oh. Glorious. It has wireframe. The 3DO, this 3DO file, which are some binary format I converted in the past, they have line information. Now I could traverse through the polygons and find the common edges and create line information for the PLG too. Because also the normals are not stored on these ones. However, I use this GP mark. So this object is also stored as 3DO, and because it has so many polygons, my search algorithm for to calculate normals was very slow at the time. There are better ways to do it. And if I grab this 3DO object, I'm not going to be able to load it in QuickBasic, of course. Then I will be able to, yeah, read the normals, the vertex normals. Because I think I'm not, for this object, I use the same format as I did here, the 3D, which is like my format in a way. It's just raw data of vertices, indices, line indices, and for those objects, it's just that. Now something is going off with the normals here. I have objects that for some reason have issues. I don't know why. Even some PLG, like I wanted to load the Formula 1. That's not Formula 1 the car, it's just some, it's this sine cosine formula. And unfortunately, look, the normals are absolutely wrong. I don't know. I should investigate what happened with those ones. And here is something funny. No, it's not that. Here's something funny. Yeah, that's irrelevant. That's something that Buckethead gave me a long time ago. We were talking about Qbasic, and I don't know how to play music. Also, good would be good to play some adlib music or something. Some FM from the Sound Blaster or whatever. But he found this example somewhere where one can offload the data. He found that example, and it will be out to the probably some PC speaker addresses. It seems very simple. That's irrelevant. Also, that's with the engine. I could be talking along. I have all the okay. So recently, this is done the same time. So recently now, with proper understanding of how QuickBasic creates code with. So I rewrote effects and tried to optimize them. and I did the plasma rotozoomer floor bump. These are not this. I just have them here, but they are not here. I haven't implemented those yet. And in most of them, you will see I'm doing some kind of weird rolling and rolling, and I'm doing this weird thing. This is very studied, okay? It's like if you calculate those and you unroll and you add the V and then you add, now initially I was doing, okay, the U equals the U plus something, but then I realized I could say 2 by the U, 3 by the U. That was not always ideal, so I tried many things. I came to this thing by testing performance and trying the better version to English. And since QuickBasic doesn't care about it's gonna read the normally in C you would say, yeah, why are you making so many variables for? It's going to be you are going to spill the registers or something. I didn't come with things like that where this is multiplied by 2, this is multiplied by 3. So I pre-calculate a lot of variables that are 1 time the U, 2 times the U, 3 times the so that I don't have to do PV plus, I do only at the end. On the PU is PU plus 8 times that. I didn't come to understand, I didn't come with this. I thought, oh, that must be optimized. I wrote it in a regular way, I wrote it in different ways, and I realized one of the fastest ways I can do it. And I have to use also there's some precalc to divide shift back for the fixed point representation. Was that, and actually, and there was a competition for the fastest rotozoomer, and there was one that Entropy, one of the QuickBasic demo programming legends, was, and I made something that it seems to be faster than his. So I do weird things like that that don't make sense, and I always unroll things a bit. I now calculate some things outside. For the y coordinates, things could be calculated, which is unlike what I did before. And I write something in the normal way and then I decide. I do that here too. I can improve things. And I made this as fast as possible for Qbasic. And I think all of these are using the BugoBuffer, isn't it? 154. I don't remember the actual. I think now I switched to the paradigm to the video. Even if a plasma could be written directly to the video, I decided let's do these effects but in the BugoBuffer video RAM, and I have some other buffers here. I might have been testing that if I put one more it's gonna break the compiler. And because I'm doing that, the plasma, I realized again this one I don't poke to the BugoBuffer, I use it directly because I'm doing 2 pixels at once again, the technique for 2 pixels at once. So it's an even faster plasma. It's a bit weird. I don't know if it does 152. Maybe it does something, but over 100 if I remember. So, okay, this is not the complete rotozoomer, and I'm mirroring it 4 times, so that in many ways it's faster. In the lower bottom, I'm not poking, I'm reading the 16-bit integer array 2 pixels at one, and I'm writing it down if I remember. And then I thought, and that's the mirror is the same here again. So half of it is calculated, the other is mirror. Why not do some nice floor money? So all of this, I tried, I tried to. It's my it's my favorite activity to write something, make it work, and then try to make it as fast as possible. And that's why I ended up with this weird code that someone might say that's bloated. It's not a. No, I have the regular one where I add the increment, and at least in QuickBasic, it made sense to add the pre-increments from 0 to 8. So I arrived at all this in a way. And that's the bump. For the bump, I'm doing something different. And I had to split two frame buffers for the bump. Because I have to keep the top and the bottom. And I don't think I don't do it with... How to explain it? In the... I'm having this buffer. In the bump, I'm doing something buffer to... I'm doing something buffer 0. I think the buffer 2 is the blob. But this one might be the bump surface. And then I do it for buffer 1. And I'm doing it twice. Upper, top and bottom. And I'm poking on the screen saying, but I'm reading from 2 buffers. And you might say, why not 2? I've seen demos that they needed to use big buffers. And they would be doing buff 1 seg is on var seg buff 1. Or maybe they would do it a bit outside. But and I've seen demos that every pixel they will get the... So they would pick. They would do the pick from buff 1 I plus 1 like the... And I decided to avoid it because if you switch from segment to segment to segment to segment in every pixel, it's not ideal for speed. This is going to one segment, but those are... It might still, it might still, if those are dynamic, it might still switch from segment to segment. I don't know, I took those decisions. In some cases, I explored which method is faster, and that's how I ended up with. And finally, to finish, this is what I did 2 months ago, and I just stopped. And recently I decided, you know what? I have some other C. I decided to shit. If I'm doing something such a nice 3D engine with environment map torsion more, which even in C I didn't. I did some stuff in C, but didn't expand it with that, and I started liking the code more here. Some ways. I'm gonna switch that and remove the bends maybe, just to show you. So yes, I started to port the QuickBasic engine on the PC. And I made some better changes. I made, okay, in QuickBasic you didn't have pointers. But now I started to correct things to be more C++ specific. But I also made a benchmark where I can pass several demo Pavla bench, Teapot PLG, Taurus PLG, Bit3D, and so, and I can run it on my Pentium, on my 486, let it run, store the results so that I can compare later, so that if I try to optimize things, write them in a different way. Oh, I haven't shown you. Shit. And I need to finish this soon, because I wasn't planning this to be. So now I become more rational with pointers, and my Object 3D finally has individual pointer for the vertices, indices. So there is no memory pool anymore. And I don't know if I benchmarked. I might have benchmarked. No, these are allocated, mallocs. So every object has its own. You don't have a big memory pool. It doesn't seem to be. Okay, I don't know if I completely benchmark. Would the pool be faster or maybe it's the same? Because internally in QuickBasic from the pool I will get an array offset, and probably it's better with pointers. So I want to simplify some things. I want to try to keep the original, but slowly and carefully improve it. Now this is something I will improve. I didn't talk about it because QuickBasic didn't have point. I did something similar that I did with my 3D engine. I'm not using Z buffer, especially in QuickBasic. I would need an extra buffer, an extra array. It would make things slower and consume more memory. And I went with my Z bucket approach, which unfortunately in QuickBasic I don't have pointer. I cannot have some linked list thing where I add. And the Z bucket approach, it works really well for some kind of sort of polygon sorting, even if it's with mistakes. Here is the Z coordinate. So I transform the points, and I need to sort the polygons based on Z. And you might have 0 to 15, 16 to... This is the Z coordinate. And I will start adding polygons in a list. Maybe here there are more polygons. Maybe here there is one polygon or no polygons. So that later I can render it in the painter's algorithm, but this is a list that expands. I find another polygon and I add it. And in 3DO I would have the cell structure which had the next pointer anyway. Next pointer, and that would point to the next cell. So I would prematurely sort my polygons and create the cell list. Okay, the next pointer would point to the cell, of course, but the cell would have a next pointer that would point to the next cell. So the default structure that you have to pass to the hardware, even through the high level API draw cells function, was very fitting with that. And I might have to create some kind of linked list. I have to see how to do it, and I have to see if it degrades the performance if I don't do it correctly. Because right now I have pools, and right now I have some arbitrary numbers that, okay, I want to have a specific Z bucket size. So now I might have an array that has 250. Like, okay, there isn't going to be more than 256. Actually, it's the same. Z. I might have that, but and I assume that, okay, in a single Z region there won't be more than 256 polygon, and that might be. Here I assume no more than 256, and that works. But if you go here, I have 64, and do you know why? Why this fails? It is because of that. It is because if it's rotated, that the screen plane is parallel to a lot of polygons. Here it fails because I'm exceeding the maximum number of the polygons that can. So I had this issue. This is fixed on the. I thought it was another bug. It was a bug with the normals or something else, but this is fixed by Greasy. So this is gonna go away. I'm gonna do the 3DO version with the linked list, so that so I am spending a lot of memory to make a lot of Z buckets where they all have 256 size. Even if maybe this is filled with 3 polygons and maybe this is filled with 80 polygons and maybe this is filled with no polygons. And I did it in QuickBasic, it was the easier. And also I have a leftovers, like I have a complicated loop that if it doesn't fit, if I reach the maximum of a bucket, just put them on the leftover and render them first. I'm going back to front. And also this is +1 because value 0 is the counter. Value 0 will tell you the how many polygons are stored here. It's pretty cool in a sense. And that was on QuickBasic though. That was on QuickBasic. That was. Here I'm gonna change it because I can have pointers and it will be easier and cleaner and less in memory. But I made the bench so that I see if I make a linked list implementation, is it possible that I will lose some of the. So now I changed the run button to not run the bench and run it directly. So now we will see how it performs on a Pentium 166. However, this is wrong because this is not bound to the video RAM. I still was getting like 700 frames per second here because of the PCI, the S3 PCI card I have. Not the Diamond Stealth, whatever I had, because it was still, but you know there was it wasn't 2000 of course, but this is the simple one. Now I think let's see the buttons. Also I have a button to change the. I'm gonna press VSync so that it moves faster. I have an issue with the timer. I'm using a low resolution timer now. And that's the combine. Now you had the. But some of the simple objects were doing like 300 frames. This wasn't far off. I think this Taurus would do 70, 80. It would do like that. 70 to 80 on my Pentium. It would do 30 FPS on my 486. But it's a 486 at 133. And it would do, the numbers are close, 130. It would do over 100. I'm confused by the keys I have. Yeah, this is the other texture. Now you can have the wireframe. Now the bit would do, especially it has to look at the here, this front. It seems about how much it would do. It would do 20 or 24. And in QuickBasic it would do, it doesn't even render it well. Even the cow would do 12. So, and generally by my benchmarks, the C version, just out of curiosity of how it compares with the QuickBasic, it goes about 3 times or in few cases 4 times. It was usually 3 times faster than the QuickBasic version. With everything. It was especially much faster in that because the video RAM drawing is 32-bit rep moves and so on, so it doesn't have the basic bottleneck. But in the heavy polygons, it would be like. So this is doing 80. In QuickBasic, it would do 30 frames or maybe 25. So it's roughly 3 times faster. And I want to continue with this engine. I want to do dual texture. I'm gonna continue and use it for future demos. Even if I have programmed other engines before, but this is something I started from a new and I have organized the code and I have done some. My other engines weren't doing any. They were doing Z buffer or they weren't doing some good sorting polygon. That's with the other. So I'm so happy with that because I finally have something. It started as a QuickBasic experiment. I'm not planning to do more QuickBasic stuff now. Maybe in the future I could use it for a demo or something. But I've ported it here, and I also tried to port it in a FreeBasic, but I don't have it here. But it wasn't much faster. Maybe it was 50% faster. The 30 frames could be 50 frames, or something like that. The 30 frame torus could be 50 or even 40 maybe, even less than 50. So it was a small improvement. But then FreeBasic normally has pointers and I haven't used them. I just make the fastest port I could do and I realized FreeBasic has. I even ported this one, yeah, I think. You has lang FB Lite, lang F. There are compatibility of like there are some things that you used in QuickBasic, the DevSeg thing, for example, that it might not. And I think with lang FB Lite I was able to port it with minimal changes. And I ported it in DOS. I tried it in DOS at the same house, so I didn't port it in Windows. But my goal for QuickBasic is do it here. You know, do it. If I do something QuickBasic, it's gonna be pure QuickBasic. There is no point to add assembly because then it's not. If I'm going to optimize with assembly, then I could convert Doom. I could convert Doom in assembly and pass it as data if I wanted. And say, look, QuickBasic can run Doom. So it's not. If I'm going to use inline assembly, as I see it as a challenge, why not write it in C and use assembly? In fact, in here I might in the C version, and I'm planning to use this for 486 and Pentium. So the make file is because it uses floating point and it does well enough in 486 and Pentium. But on my 386 I'm going to use an old engine. So I might have different engines. So this is for 486 and Pentium demo or game or whatever. That's the plan. And I had some GPP code, but this is compiled with Whatcom, by the way. I have not done the work to compile it with the GPP, but there is some. This is taken from another engine. Now, I need to get a higher resolution timer because I'm using this simple timer, 18.2 times per second, and I need to update my timer, and I didn't bother to look how to do that properly. Now, I have only tried the 320. I haven't tried the higher resolution. I used to have this is scrapped from an old project. I used to have this and was able to change it, but recently, now I'm selecting. Recently, when I uncommented task for mode and I choose the other one. At least in DOSBox, I got a crash for some reason. I haven't tried on the real hardware. Maybe I haven't set up VESA in DOSBox, or I don't know. No, maybe it should work. So I plan to. I'm so curious to do this on a Pentium high resolution and make it properly scale with the aspect ratio. So I could I could try to compile it for DJGPP. Unless I have extra code that need change. I don't know, like some palette code. Yeah, I have both. So it could be even faster with DJGPP. Maybe I have some, okay. Even for the palettes, I have both. Okay. I could easily, just that I don't have DJGPP set up. I have it on a Pentium 3. I could make a DJGPP version just for curiosity how better it performs. So if I had the bench, this is gonna cycle through every object, every style, dots, wireframe, flat guru, environmental guru, and so on. And environment, it will do 15 seconds for each, and this is, yeah, you can set it up. I could have it as an argument. It will run through all the thing and output the results. I don't have them here, maybe I have them here. And I have them at different 486 and 586. Yeah, I don't have. Okay, I could make it in the CSV. This is dots, wireframe. Those objects don't have wireframe, so I skip them and put 0. Flat. No, wireframe. Flat, guru. Environment texture without guru. Environment texture mixed with guru. And that's on the 386. Even on the 386, the nice funk torus does a 33. And the bit and cow goes much slower. It's pretty cool. And I'm excited because, yeah, as I said, the rasterizers, draw edges, texture, guru. I also try to be sub-pixel here, like I don't collapse the edge coordinates. So these now are, they are fixed point. I don't collapse them to the pixel. And I interpolate and then collapse them. Okay, I collapse them here for the pixel loop. But those and those, this is the skyline. Even outside, even in the vertical, where I go through the edges. And this has improved a lot of things. I do calculate a triangle graph so that I don't have to recalculate every time the offset, the DU, DV, DC, and so on. I calculate them one per triangle for the whole triangle. So there's some good stuff here, but they can be improved. And the thing is, in 386 and 286, I used to write, at least for the flat and the guru especially, I write a very optimized assembly version. That really improves split, and I think there are a lot of things I could improve. The other thing is, when I read PLG, the PLG polygons might have more than triangles. They might be, if you open the vase PLG, it's in, okay, it has the points, and then it has, this is the material. It refers to something, I don't know what. I could take it and colorize it in a different way. And this is, okay, all of these are codes. The number of points are 4, the number of indices, and there are 4 indices. And then here it has 12 indices for the top and the bottom. And I take care of that, but right now, because I'm working with triangles, and at least for most modes, it's preferable to work with triangles to have the stable grad calculation. I have to do a pre-step where if I find something more than triangles, I will calculate the actual number of triangles Actually, this is a pre-step that I get. I'd like to do that better, so that I set up the object with the actual number of triangles, and I go again here, and if number point is 3, I add. Else, I'm going through that, and I'm having a way to split the nigons to triangles and add them separate. But I was thinking, if I'm flat shading, like the vase, the torus, for example, the torus is all fours. They are all quads. That would be especially useful in the 3DO, which could be converting things to triangle unnecessarily. But even here, at least the flat shaded, I could write a flat shader that is rendering quads. There are many optimizations I can do. I was watching some more demos and reading some other techniques for faster environment mapping, faster fog, and man. Anyway, I think it's this video was longer than I thought, and it's an update on the things. I needed to be somewhere on the city today before 12 to the post office, so it's time to. I think I have time for that to stop it, but I'm so excited with that. I will focus more on that. I might. I have the hardware render engine on the 3DO, but it was loading the 3DO object. I will add support to load those PLG and have nice torus and all these kinds of objects. And see what I'm doing there. See if I'm converting things to triangles or if I'm rendering things as quads, so that I can apply that too. I might do soon an update on my 3DO experiments with the PLG loader and examples of more objects. It will be fun. Maybe I can load many of them on the scene and move around. That would be impressive. Also, they will be flat shaded for now. And anyways, guys, I guess that's it. Sorry for the long video, but this is what I was doing, among other things that I haven't revealed yet. Yeah, hope for some good updates with 3DO and other stuff. Bye.